Hello, welcome to percent error. Today we're going to look at how to find the percent error and the absolute error of two given problems or two given scenarios in the same problem. So in example 1 it says Mai is estimating the weight of her bike. The actual weight of her mountain bike is 13.4 kilograms and May's estimate is 12 kilograms. Find the absolute error and the percent error of May's estimate. If necessary, round your answers to the nearest tenth. Well, to find the absolute error, we're looking at the actual versus the estimate. So to find the absolute error, we just subtract the values. So I'm going to do 13.4 minus 12, which is 1.4 kilograms. Okay, so that one was easy. Just for absolute error, just subtract the two guesses and the guess and the actual one, and always put the big number first. And then to find the percent error, we're going to say that the error, so 1.4, we're going to make an is statement, and we're going to say that the error, so 1.4, make an is statement, is what percent of, and then we're going to use the actual value, 13.4. Okay, so I got my 13.4 because of the actual value. Now I have my is and my of. I can set up my percent proportion. It says what percent, so I don't know, so it's going to be x over 100. And then is goes on top, so 1.4 is. And then of 13.4 goes in the denominator. Now I'm simply going to cross multiply and divide here. So I'm going to do 100 times 1.4, which gives me 140. Equals 13.4x. And now I need to divide here. So I'm going to divide both sides by 13.4. I'm going to use my handy dandy calculator. 140 divided by 13.4. That equals 10.44. There's some numbers after that, but we only need to round to the nearest tenth, which is right here. So the 4 doesn't round the 4, so it's just 10.4% is my percent error. So let's look at another one. In example A, it says a police officer estimated the distance from one side of the street to the other to be 13 meters. The actual distance was 13.7 meters. Find the absolute error and the percent error. So let's find the absolute error. Remember, for absolute error, we're going to take the distances and subtract them. So that's going to give me 0.7 meters. Now I need to make my is statement. My error is what percent of the actual distance. So 0.7 meters is what percent of the actual value, 13.7 meters. Now I have my is and my of. I can set my proportion up. So it says what percent, so that's going to be x. So x over 100 equals 0.7, 0.7 over 13.7. I'm going to cross multiply here. It's going to move this one 2 spaces, so I'm going to get 70 equals 13.7x. Again, here I'm going to divide by 13.7 on both sides, so 70 divided by 13.7. I'm going to use my calculator here, so 70 divided by 13.7. And that gives me x equals 5.0, excuse me, 5.10 and some numbers after that. 0 cannot round the 1, so my percent error is 5.1%. Alright, let's look at one more example real quick. Ryan is estimating the height of his office building. The actual height is 39 feet. Ryan's estimate is 35 feet. Find the absolute error and the percent error. Okay, so let's look at absolute error. The absolute error, remember we subtract the values. Okay, so 39 feet minus 35 feet equals 4 feet. Now we need to find the error. So to find the error, we need to say that 4 feet is what percent of the actual value. Actual height is 39 feet. Remember that this is the actual value. Okay, so 4 feet is what percent of 39. So I have my is and my of. So I say percent over 100 equals, and then what percent of 39? So 4 over 39. Of 39, 4 feet is. Now I can cross multiply and divide. And this should be x, excuse me. 4 times 100 is 400. X times 39 is 39x. I'm going to divide both sides by 39. Use my handy dandy calculator and get that 400 divided by 39 is 10.25. With some numbers after it. The 5 can round up the 2, so it's going to become 10.3%. So here's my percent error, and here's my actual error. Alright, so remember, subtract the values, set up your statement, set up your proportion, solve for the percent. Good luck.